So following are the learning objectives of the present video. Soil introduction, formation of soil, physical properties of soil, chemical properties of soil, biological properties of soil, and soil fertility. So let's start with the brief introduction of soil. Our environment is composed of atmosphere, earth, and water. The interaction between atmosphere, lithosphere, hydrosphere, and biosphere is continuing for years together. Soil is one of the three major natural resources alongside air and water. We get everything for our living from soil. Soil is a natural medium on the surface of the earth without which there would be no life. Soil is made up of minerals and decomposed organic matter along with air and water. Soil can create a habitat of fungi, bacteria, and related organisms which in turn feed and support plant life. Healthy soil is fundamental to the quality of food it produces. Soil formation is a complex process and it can take 100 to 1000 years to create 1 inch of topsoil. Climate, topography, living organism, and the type of parent material determine the nature of the soil. Parent materials comes from breakdown of underlying rocks or from deposit brought by streams, rivers, gulfs, hills, wind, glacier, or organic plant residues. Over time, these materials are weathered by freezing, thawing, wetting, drying, heating, cooling, erosion, and chemical reactions. Eventually, the parent material is divided into 3 horizontal layers. The top layers consist of mostly organic matter and biological activity. The middle layer is the zone of maximum material accumulation and the bottom layer is the mostly parent material, but it can alter. The topsoil is important as it is foundation of the life form. Crop quality directly depend on the quality of agricultural soil on which it grown. The fundamental property of soils are divided into 3 major categories, namely physical, chemical, and biological. Soil comprises of minerals, organic matter, water, and air. The composition and proportion of these components greatly influences the physical properties, including color, texture, structure, and porosity. These properties regulate and affect the air and water movement in the soil. Organic matter includes residues of dead plants, animals, and organisms and nutrients such as nitrogen, potassium, and phosphorus, which are necessary for plant growth. Which contains 30% or more organic matter is known as organic soil, and soil which contains less than 30% organic matter is known as mineral soil. Organic matter in the soil improves water infiltration and decrease evaporation and increase water holding capacity. Also, the organisms present in the organic matter of the soil help to convert it back to nutrients. Also, the organisms help to create crumbs in the soil which can improve the cultivation. The term pH is used to indicate the level of acidity or alkalinity of soil. It range of pH values of good soil lies from 5.5 to 7.5. Below pH 7, the soil is termed as acidic, and above pH 7 is alkaline. The pH of soil is important for the type of vegetation that will grow and the type of organism that will live there. Also, presence of organic matter in soil has a close relationship with soil pH. Soil richer in organic matter is acidic in nature as a result of degradation of various substances that produce acid in soil. The availability of nitrogen, potassium, calcium, magnesium, sulfur tend to decrease with the decreasing pH since condition with acidity. The soil such as withering and plant uptake also result in removal of these nutrients or decrease microbial activity. Soil, the abode of millions of organisms. It is the most abundant and diverse ecosystem on Earth. Soil microorganism includes both plant and animal forms, ranging from submicroscopic viruses to earthworm to large burrowing animals such as gophers and ground squirrels. Major microbial groups in the soil are bacteria, fungi, algae, and protozoa. These feeds on plant residues, burrow the soil, and help in aeration and percolation of water. Soil microbes also control the quantity and forms of various chemical elements found in soil. Most notable cycles of nitrogen, carbon, sulfur, and phosphorus happens in the soil which increase the soil fertility. Soil microbes convert organic forms of element into their inorganic forms and liberate ammonia, carbon dioxide, sulfate, phosphate, and inorganic form of other elements. This process is known as mineralization. This is the major nutrient cycle in all major ecosystems of the world. Besides, their rates of production of inorganic form from various organic form, soil microbes, particularly soil bacteria, also controls the form of ions in which these nutrients occurs. Thus, physical, chemical, and biological property of soils affects many processes in soil that is suitable for cultivation and other purposes. Fertility of soil is closely associated with the property of soil and is defined by its capacity to hold water and nutrients and supply them to plants when they needed them, independent of direct application of nutrients. Transfer of nutrients from soil's organic matter to the mineral stage and building up of soil's organic matter depend on the activity diversity of soil's organisms. Soil fertility can be described in terms of soil organic matter with the good living conditions for soil organisms and growing condition for roots, the availability of nutrients, the soil water holding capacity, and its biological activity. A major part of soil microbial biomass is composed of fungi, mycorrhizae, which are important representative of soil fungi, forms a symbiotic relationship with most plant roots. The plant roots provide sugar and the growth of other fungus. The fungus in turn explores the soil and brings back water as well as nutrients such as phosphates, zincs, and copper that are not easily available to the plant. Mycorrhizae enlarge the rooting zones of plants and enter small soil pores where plants' roots cannot access. Proper soil fertility management is very important to know how nutrients become available in the soil. This is done by protecting the soil and feeding it organic material and then letting it feed the plants in balanced way a good organic soil.